Hello once again. This video is all about trigonometric function. Now let's consider an angle theta, and this angle theta is placed in a rectangular coordinate system. So it's short review. So an angle has two sides, the initial side and the terminal side. And this angle is rotated in a counterclockwise direction. So this angle is in standard position. So what is angle in standard position? So angles are said to be in standard position if the initial side of the angle lies on the positive x-axis. So take note, in the rectangular coordinate system, there are two axes, the x-axis and the y-axis. So the positive x-axis starts from the origin, the horizontal starts from the origin and extends towards the right. So this angle is in standard position. So it's only the terminal side that will rotate. So consider again a point P, and this point P has coordinates x and y. So the x coordinate and the y coordinate. So again, take note that x coordinate is considered as the abscissa of the point, and the y coordinate is called the ordinate of the point. And the x coordinate is actually the distance, directed distance of the point from the y-axis, and the y-coordinate of the point is directed distance from the x-axis to the point. Okay, so if we project a line from point P towards the initial side of the angle, and the intersection of this projected line and the initial side is denoted as point Q. So we can form here a right triangle, POQ. So let POQ be a right triangle with the acute angle theta. So X here is the adjacent side of theta, and Y is the opposite side of theta. Now the distance from point O to point P is considered as R, and R is actually the hypotenuse of our right triangle. So to solve for the length of the hypotenuse, R, we use the Pythagorean theorem, where the length of the hypotenuse, or the square of the hypotenuse, is equivalent to the sum of the squares of the other two sides. So R squared is equal to x squared plus y squared, or R is equal to the square root of x squared plus y squared. Now, we have here a radical. Okay, so the square root of x squared plus y squared is a radical. So radicals has two answers, so plus and minus. So for angles, for the value of uh, r is always positive. Now let's consider again the same triangle, which is in standard position. Okay, and point P is on the terminal side of the angle theta. So let's have the definition of the trigonometric functions. So let theta be an angle in standard position, and let pxy be a point on the terminal side. So if r is equal to the square root of x squared plus y squared, and it is defined as the distance from the origin to point P, then we have the six trigonometric functions. Sine theta is y over r, so meaning opposite side of the angle over the hypotenuse. Cosine theta is x over r, adjacent side of the angle theta over the hypotenuse r. And tangent theta is equal to y over x, the opposite side over the adjacent side. And take note, x must not be equivalent to 0. Because if x is 0, then the tangent function is undefined. Next is cosecant theta, which is r over y. So y here must not be equal to 0 also. Okay, and secant theta is r over x, and x must not be equal to 0. Cotangent theta is equal to x over y and y is not must not be equal to 0. Otherwise, the values are undefined. So what if our angle is on this side of the rectangular coordinate system? So let us review the different quadrants of the rectangular coordinate system. So take note that the Cartesian plane or the rectangular coordinate system has two axes, and these axes intersect at a common point O. Okay, so when these axes intersect, it forms a quadrant. No, it divides the plane into four, and we call it quadrants. So the first quadrant, so the rotation or the assignment of the quadrants is in a counterclockwise direction. So quadrant one is the quadrant where your x is positive and your y is also positive. Second quadrant or quadrant two, your x is negative, y is positive. Quadrant 3, x is negative, y is also negative. And then quadrant 4, x is positive, y is negative. So if in quadrant 1, so let's have the six trigonometric functions. So recall, so we have sine, cosine, tangent, cosecant, secant, and cotangent. So take note of the, so that you will not forget, no? So katowa and Shoshakawa. Okay, so in the first quadrant, since x is positive and y is positive, then meaning all the six trigonometric functions are positive on the first quadrant. So we call it all. We assign this quadrant as all. All means that all the six trigonometric functions on the first quadrant are all positive. Then second is 2. For the second quadrant, we have sine. So since x is negative and y is positive, so meaning those with the x values, okay, in the ratio of the six trigonometric functions will have a negative value. So we have cosine, tangent, secant, and cotangent. So meaning it's only sine and cosecant which are positive on the second quadrant. So we have here sine. So actually, if we have to review the um, trigonometric identities, cosecant is actually the reciprocal of a reciprocal function of sine theta. You can see here y over r and r over y. So sine and its reciprocal function, which is cosecant, okay, are the only functions positive on the second quadrant. Now, in the third quadrant, x is negative, y is also negative. So those functions which contain y and x, okay, are all negative. So we have this one is negative because r is always positive. So negative divided by positive is negative. So same with this one, positive over negative is negative. And then we also have cosine, which is x over r, negative. And second is r over x, also negative. And tangent. Now, for the tangent and the cotangent functions, okay, tangent and the cotangent functions. Now, since y is negative and x is negative, then negative divided by negative is positive. So therefore, tangent and cotangent are the only functions positive on the third quadrant. So we can assign this quadrant as for the tangent. So tangent and its reciprocal function, cotangent, are the only functions positive on the third quadrant. Now, on the fourth quadrant, x is positive, y is negative. So looking at the six trigonometric functions, those with the y values, we have sine, cosecant, tangent, and cotangent are negative on the fourth quadrant. So it's only cosine and secant are the only functions positive on the fourth quadrant. Okay, so we can assign the fourth quadrant for cosine and its reciprocal function, which is secant. the only functions positive on the fourth quadrant. So a summary of that. So we have here first quadrant, all the functions are positive. Second quadrant, it's only the sine and the cosecant function are positive on the second quadrant. Third quadrant, tangent and cotangent. Fourth quadrant, cosine and secant, okay, are the only functions positive on the fourth quadrant. Okay, so now let's solve the six trigonometric functions of an angle. So for example, if P is negative 3, 4, so meaning x is negative 3, y is 4, find the six trigonometric functions of theta. So x, our point is negative 3, 4, x is negative 3, y is 4, so solving for the value of r squared equals x squared plus y squared, then r equals 5. So take note, r is always positive. So solving for the six trigonometric functions, let's start with sine. Sine is y over r, so 4 over 5. Cosine is x over r, so negative 3 over 5. Tangent is y over x, so we have 4 over negative 3, or you can write it this way, right? So you can review that in algebra. Then cosecant is r over y, so 5 over 4. Secant is r over x, 5 over negative 3. Cotangent is x over y, or negative 3 over 4. So, or you can write it this way. So that's it for the six trigonometric functions of the angle where the terminal side, where point P, negative 3, 4 lies on the terminal side of the angle. Okay, next. So for example, we have P equals negative 5, negative 12. Find the six trigonometric functions of theta. So since x is negative, y is also negative. So the angle or the point is located on the third quadrant. Okay, so rotating in standard position and rotating counterclockwise. So let us solve for the six trigonometric functions of theta. So point P is negative 5, negative 12. X is negative 5, y is negative 12. So solving for the value of r squared equals x squared plus y squared, where r is equal to 13. So again, r is always positive. So solving for the six trigonometric functions of theta, we have sine y over r, so we have negative 12 over 13. Cosine, negative 5 over 13. Tangent, negative 12 over negative 5. So take note, negative divided by negative is positive. Cosecant theta is r over y, so 13 over negative 12, or you can write it this way. Then secant theta is r over x, 13 over negative 5, or negative 13 over 5. And cotangent equals x over y, or negative 5 over negative 12. Or you can, since negative over negative is positive, so we have 5. So take note that on the third quadrant, it's only the tangent and the cotangent functions are positive on the third quadrant. Now next, we have if secant theta equals 17 over 15 and tangent theta is less than 0, find the other 5 trigonometric functions of theta. So take note, secant is greater than 0, meaning positive, and tangent theta is less than 0. So on which quadrant is secant positive and tangent negative? Sorry, so tangent negative. So secant is positive on the fourth quadrant and tangent is negative. Secant is positive on the first and fourth quadrant, and tangent is negative on the second and fourth quadrant. So common between the two is fourth quadrant. So thus the angle is located on the fourth quadrant. So the terminal side of the angle lies on the fourth quadrant. So since it is on the fourth quadrant, so therefore x is positive, y is negative, and r is always positive. So x is positive, y is negative. So since the given function is second and second is r over x, so r is 17 and x is 15. So let us solve for y. Okay, r is 17, x is 15. Solving for y, so y squared equals r squared minus x squared from the Pythagorean theorem. So solving for y equals the square root of r squared minus x squared, substitute. Then y is equivalent to negative 8. Why negative 8? Since our angle lies, or the terminal side of our angle lies on the fourth quadrant, where x is positive, y is negative. So therefore, y is negative 8. So since y is equivalent to negative 8, then sine theta is negative 8 over 17, so y over r. Cosine is 15 over 17, x over r. Tangent, so y over x, so negative 8 over 15, or you can write it this way, negative 8 over 15. Negative 8 over 15. Cosecant, r over y, so 17 over negative 8. Cotangent is x over y, so 15 over negative 8. So we have here the other 5 trigonometric functions of theta. Next, if cotangent theta is 7 over 8 and cosine theta is less than 0, find the other 5 trigonometric functions of theta. So let us locate first the quadrant where the terminal side of our angle lies. So since cotangent is greater than 0 and cosine is less than 0, so cotangent is positive on the first and third quadrant. Cosine is negative on the second and third quadrant. So since they coincide on the third quadrant, then the angle, or the terminal side of our angle, is located on the third quadrant. So on the third quadrant, x is negative, y is negative. Now, since the given function is cotangent theta, and cotangent is x over y, so since it is located on the third quadrant, so x is negative 7 and y is negative 8. So if x is negative 7 and y is negative 8, then the third side, which is the hypotenuse r, so r is equal to the square root of x squared plus y squared. So r equals the square root of 113. So take note, r is always positive. So therefore, the other 5 trigonometric functions, let's start with sine. So negative 8 over square root of 113. So rationalizing, we have this uh, value. So negative 8 square root of 113 over 113. Then for cosine, x over r, negative 7 over the square root of 113, or negative 7 square root of 113 over 113. Then tangent is y over x, so negative 8 over negative 7, or positive 8 over 7, since negative divided by negative is positive. Next, cosecant is r over y, so square root of 113 over negative 8, or negative 8 square root of 113 over 8. And second, r over x, so we have the square root of 113 over negative 7, or negative square root of 113 over 7.